Hello. We're going to find the derivative of the square root function. We've definitely never done this before, so let's do this. This is going to be quite intense, but it's doable. So watch this method of doing the derivative of a square root function. So find f prime of x. We'll find f prime of x. We'll go with a definition of the derivative, which is that, and then we'll have f of x plus h minus f of x. We've done this 100 times over h. So that's our definition that we're going to go by. And so we're going to plug in x plus h into this function. So we have, I'm going to leave the limit thing off and bring it back at the end. So we're going to do x, so it's going to be the square root of x plus h underneath minus f of x. Well, f of x is the square root of x, so that's just the square root of x. And just like all the other ones, you plug it in, you plug x plus h into the original function, and then f of x at the end, you just write the function down. And that's all over h. But the problem is, how do you simplify this? How does one simplify that? Well, it has to do with something called the conjugate. And a conjugate, for example, if we go over here to the side of our paper and we do a, say we had a minus b. And I multiplied this by a plus b. Well, when that happens, I'm going to, and especially, well, I'll tell you what. Well, let me go ahead and continue with that, but let me get rid of those parentheses. If I do this, like I was foiling it, I'm going to wind up getting a squared minus b squared. So those middle terms are going to drop out. So if I had something like the square root of a minus the square root of b, make that a little bit brighter, I could multiply that by the square root of a plus the square root of b. And when I did this, if you foil that all the way through those, the O and the I of foil will go away. They'll cancel each other. So what you'll have on something like this is A minus B. And this is called the conjugate. So what I have to do is come up here and simplify this top by multiplying by the numerators, or this top's conjugate. In other words, the square root of x plus h plus the square root of x. And I have to do that on the top and the bottom. So plus the square root of x, like that. So here's what happens. On the top, much like this example right here, stuff's going to cancel in the middle. The OI of FOIL will cancel. And so here will be my new top. So on top, I'm going to have x plus h, radical x plus h, times radical x plus h. That's just going to be x plus h. And then the last thing is going to be minus x, because that's the square root of x times the square root of x. Remember, that's just like you're foiling that. Let me just put some arrows on here so you know what I'm talking about. That's like first and last. And you're skipping, the conjugate makes you skip the outside and the inside, the OI. Okay? And it makes things clean up. That's the whole point. Now on the bottom, we have, get back to the bottom color here, we have H times all this. Now I'm not going to distribute the H through there yet, and you'll see why in a minute. So I'm just going to plop this down plus radical X, like that. Okay, I think you might be able to see where I'm going with this now. The next step would be to clean the top up. These x's are going to cancel. That cancels that, and I just have h left on top, which is great, because I have an h out here all by itself that I can just cancel. All right, but let me go ahead and show that. I'm going to do a bunch of rewriting. Calculus is a whole bunch of rewriting stuff. Okay, and then you can see that this h and that h are going to get canceled. But what's left on the top, of course, is a 1. So these are 1s here. All right. So on the next to last layer, we have a 1 on the top, and on the bottom, we have the square root of x plus h plus radical x. And remember not to forget the original definition here. This is a limit as h goes to 0. So at this point, we need to plug 0 in for that h right there. All right. So that turns into 1 over the square root of x plus 0, right? Because if I plug 0 in right there, that's just going to be x plus radical x. Now, can I simplify that one more time? Of course. So it's going to be 1 over, and this is just like variables, just like x plus x equals 2x. The square root of x plus the square root of x is 2 radical x. And this is accepted to, I know, you're usually taught don't leave radical in the denominator. And in this example, pretty much every book I've ever seen, it's left down there. So this would be your final answer. Okay, so 1 over 2 radical x. If you need to watch that again, feel free. Have a good one.